Hello and welcome to lesson 2.4 of our Math 111 course. So in this class we're going to kind of start putting together everything we know to work towards solving equations that have these rational expressions in them. And we're pretty much going to summarize or narrow everything down into two steps. Okay? What we're going to want to do is let's eliminate all the denominators we can. Okay? Or kill off, eliminate all the denominators. Because really when we're solving, most people don't want to deal with fractions. And then the second thing we're going to have to do, because we're getting rid of these denominators, we're going to need to be careful. If there's any x's in the denominators, I guess the second thing we're going to do is then solve. And I guess there is one more step. It's very important. We 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 must check our solutions versus the denominator. What I mean by that is we need to check our solutions, not denominator, domain. Need to check our solutions to make sure that they are in the domain. So remember our very first lesson in this chapter. I said, hey, let's talk about domain for a few seconds, and we noticed that there were some values of x that were not allowed. And so we want to be careful that when we're solving, if we get two answers, we want to check both answers, and it's possible one or both or none may be not allowed in the domain. They may make the rational expressions undefined. So we've already in algebra, in early college algebra, we know how to eliminate all the denominators. We know how to solve. But now, since we're going to make these a little harder and put x's in the denominators possibly, we need to really worry about checking to make sure our solutions are valid solutions and they work in the domain. So let me start with the first example. This one will not need step 3. You'll see why when I start with it, but this one's a refresher on how we handle solving with fractions everywhere. So 4x over 5 plus 2 over, sorry, I want to go 3 over 2 equals 3x over 10. Okay, so the reason I won't have to worry about checking the domain to make sure my solutions are allowed or not allowed is because there are no x's in the denominators. So the x's here should be allowed to be everything. Okay, now if we want to be able to solve something with nasty fractions like this, we need to look at all the denominators. I have 5, 2, and 10. And we're going to want to multiply both sides of the equation, everything through, by the same number so that we eliminate all these denominators. Now, if we look here, if I multiply everything through by 5, that won't work because there'll still be some fraction here, and 5 will not cancel 2. If I multiply everything through by 2, 2 will not cancel 5, and 2 and 10, there'll still be some denominator. But sometimes when you have three numbers, if you're lucky enough, the third number, one of the numbers, will be a product of two others. What that means is 5 times 2 is 10 is what I'm saying. If I choose to multiply everything through by 10, I get very lucky. Now, there is a number like this for every set of equations I will give you here that have a bunch of fractions. There's a number, a multiple, that we can multiply by that will cancel out or divide out all the fraction parts, and I will no longer have any rational expression pieces in my equation. So let's look at this first one. If I multiply by 10 here, oh, well, 10 divided by 5, that would reduce to 2. And 10 divided by 2, that would divide down or reduce down to 5. And 10 divided by 10, that would divide to 1 or be gone. So what am I left here with? I'm left with 2 times 4x plus 5 times 3 equals 3x, or 3x. The 10s are gone there. Now, I know you could go ahead and multiply those. You probably should go ahead, but, you know, if you're really cautious and want to write out the steps, the 10 and the 5 reduce down to 2. I'm just left with 2 times 4x. Now, 2 times 4x, you know, is 8x. And 5 times 3, the 10 and the 2 reduce down to 5. Well, we know 5 times 3 is 15. And then I have 3x here, the 10 and the 10 divided out to 1. So now this is just a simple equation to attempt to solve. Let's see, I could subtract 3x over to this side. Subtract 3x from both sides to get my x's together. They give me 5x plus 15 equals 0. Now I want to subtract the 15 to start working on getting x by itself. Subtract the 15 from both sides. So 5x is equal to negative 15. And then finally, in the last step, I'll divide both sides by 5, and you'll find that x is equal to negative 3. Now, if you wanted to, you could check this and put negative 3 in here and see if it works out. But I'm going to go ahead and tell you I'm pretty confident it is, because none of the x's are in the bottom. The domain here will allow every single x value. Okay? Now, let's look at another example where x's are in the denominator, and so I will have to worry about what is allowed in the domain. So let's go with one like this. 3 over x minus x plus 21 over 3x equals 5 over 3. And so I want to do the same thing. I want to find a number that I can multiply everything by that will cancel out or divide out all these fractions. Okay? Well, I have x. If I multiply by x here, x is not going to cancel 3. I have 3. If I multiply by 3, 3 is not going to cancel x. But I do have 3x, which happens to be the multiplication of these two terms, 3x. So if I multiply everything by 3x, let's say 3x, the x's would cancel. 3x, the 3's would cancel. And 3x would cancel. So we get extremely lucky and extremely happy that I can just multiply everything by one number, or one term, or one factor, I guess I should say. And that will reduce out or divide out all my denominators, and I will no longer have any fractions. So let's see, x and x cancel here, leaving me with 3 times 3. Let's go ahead and do that to move a little faster. That's just 9. Subtract, I will go ahead and caution you once again to put parentheses around things with multiple terms on tops and bottoms of fractions. But we're lucky here, 3x cancels with 3x, but I'm going to keep these parentheses for a second. Okay. And then let's see, 3 cancels with 3 or divides out with 3, and I'm left with 5 times x, or 5x. Okay, well this is once again looks much nicer, no fractions in the way, so I should be able to handle this to solve for x. Now, I did want you to be careful with big terms like this that are being subtracted or might have things distributed to them. You need to put parentheses around any part of these fractions that have more than one term to them, because stuff's going to have to be distributed to them like this subtraction sign. So I'm going to have minus x and minus 21 equals 5x. Now I do have some like terms here I can combine. 9 minus 21. Oof, what is 9 minus 21? So if we would just pull up a calculator, 9 minus 21 is negative 12. Alright, so it doesn't matter what order we write this in. Okay, let's get the x's on the same side. So I'm going to add, I wanted to change colors here. Add this x over to this side. So I have negative 12 equals 5x plus x is 6x. Now we're almost there. I can divide both sides by 6. And that will be negative 2. X equals negative 2. Now, I did have x's in the denominator, so we need to plug in negative 2 into all of these denominators and make sure they don't end up being 0. So if I put a negative 2 here, the denominator is just negative 2. If I put a negative 2 here, the denominator is just negative 6. Were either of them 0? No, so we're okay. So the answer really is, we've checked the denominator, the domain, negative 2. Okay, well that wasn't too bad. Well, let's keep working towards this. What if I give you something, not little 3 fractions, but something like this? Let's say x plus 6 divided by x minus 2 is equal to 2 x plus 2 divided by x minus 2. Okay. Well, we get lucky again here, thank goodness. because they have the same denominators. Now, there's no parentheses showing, but you could write parentheses around all these pieces. Just to notice that this has an x minus 2 on the bottom. This has an x minus 2 on the bottom. We're going to follow the same steps and multiply everything through by some factor that will cancel out all the denominators. And we're lucky here because these are the same, so x minus 2 works for both. So it'll cancel that, it'll cancel that. And so we end up with x plus 6 equals 2x plus 2. Well, this is not hard at all. We need to distribute, get the x's on the same side, solve. This looks just like an early algebra, college algebra problem. Not super duper difficult. So we'll distribute this. That'll give us 2x plus 4. We'll bring down this side, x plus 6. Let's see. Let's get the x's together. I'll subtract x from both sides. And that will give us 6 equals x plus 4. And then I'll need to subtract 4 from both sides. And so x equals 2. Okay? Now, we are going to need to check x equals 2 in the denominator. So if I take my x equal 2 and stick it at 2 minus 2 is, 0. This is not allowed. This can't be my solution because x cannot be 2. Now, sadly, this wasn't one that factored and gave me like 2 solutions, so I don't actually have a solution here. There's no real solution, okay? Because this x equals 2 is not allowed by the denominator. It would make it undefined. And since I have no other solutions, I don't have 2 or 3 answers, I have to throw that one out, and I end up with no real solution. Okay. Sadly, the denominator rejected that. It's not in the domain. Okay. Let's look at one more example that's a little bigger and more fun and a little bit more intense. Maybe this will be more entertaining. So let's look at one that's 2x over x minus 3 plus 6 minus 2x over x squared minus 9 equals x over x plus 3. Okay, so this looks a little bit bigger and badder, but it's not too bad. I would say the first place I would start is by noticing that this would factor. This is horrible notation, but to save us time, I'm doing some scratch work to remind us this is one of those special factors. And x squared minus 9 factors into x plus 3 and x minus 3. Oh, notice this has an x minus 3. This has an x plus 3. So if I multiplied everything through by this, it would cancel all the denominators. So we'll do that. X plus 3 and x minus 3, x plus 3 and x minus 3, x plus 3 and x minus 3. Okay, I'm going to get rid of this so that it doesn't look messy. Okay, so now we're excited here because we have stuff that cancels. X minus 3 cancels with x minus 3. And so this term becomes 2x times that. Maybe I'll go ahead and distribute it. 2x times x is 2x squared. 2x times this plus 3 becomes 6x. Okay, good. Add parentheses there. Now x plus 3, x minus 3 cancels with that because this is x plus 3, x minus 3. So I'm just left with 6 minus 2x equals sign. X plus 3 and x plus 3 cancel. I have x and x minus 3. So I need to distribute this x to the x minus 3. So that'd be x squared minus 3x. Now, I have x's everywhere. I probably want to get everything on one side. Notice I have x squareds too. So this is exciting because I might need to use the skills I have to factor to solve this. So let's subtract everything on one side. We can go ahead and combine some like terms too. While we do this, we'll do a few things at one time. So 2x squared, we're going to need to subtract x squared from each side. 2x squared minus x squared, that is just x squared. If you look, I need to move this 3x term over. It's a negative 3x, so I'm going to add 3x. Let's see, 6x plus 3x is 9x. I also have minus 2x, so 9x minus 2x, that is positive 7x. Let's bring down this plus 6. Okay, and we've moved everything from this side, so there's 0 over there. So this looks very familiar. This looks like what we've done not long ago, where we're going to try to factor this and use this zero product property, and we'll hope that we find the solution. Let's see. Let's see if it's factorable. So what two numbers multiply to positive 6 to add to positive 7? Oh, how about positive 1 and positive 6? 1 times 6 is 6. 1 plus 6 is 7. Beautiful. Now I can set each of these, I'm going to go over here and work, set each of these equal to 0, and find that I have two solutions. X equals -1, and if you subtract the 6 over, you'll see -6. Alright, that feels good, but what do I need to do before I just say I have two solutions? I need to check them versus the denominators to make sure they work for the domain. Well, let's see, 3 would not be allowed, and -3 would not be allowed, and 3 or -3. Okay, are either of these 3 or -3? No, so these are good. I actually have two solutions this time. So that's interesting. That's okay. That can happen. Alright. So, like I said, sometimes one or both or neither of these will not be allowed. Sometimes we have one answer, two answers, 0 answers. We kind of saw all of it in these few examples. So go try the homeworks. If you do have questions, please email me, let me know, reach out to me. Good luck and have fun doing it.